All right, today we're going to be talking about perpendicular lines. So again, just kind of some theorems, some things to go over about perpendicular lines. If two lines intersect to form a linear pair, so again, a linear pair are two lines that are connected to each other and add up to 180 degrees. So a linear pair, so again, they are adjacent and add up to 180 degrees. So like, for example, if angle 1 is congruent to angle 2, then they have to be congruent, because if they're exactly the same, the only way you can add up to 180 is if they're both 90, is if this is 90 and this is 90. Otherwise, they're not going to be congruent. They can't add up. If one's 87 and one's 93, they're not congruent. They're not the same. Kind of a similar way or similar idea is if two lines are perpendicular, then they intersect to form four right angles. So you've got a right angle here, you have a right angle here, you have a right angle here, and you have a right angle here. If two sides of two adjacent angles are perpendicular, then their angles are complementary. Remember, complementary means add up to 90 degrees. So again, if I take whatever angle 1 is plus angle 2, because it tells me right here that box means 90 degrees, I know that angle 1 plus angle 2 equals 90 degrees. All right, perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Now, the important thing is to note it's given to me that both of these lines are parallel. Again, this arrow right here means parallel. So if I don't have that parallel signifier, then I can't necessarily say that, okay? So if they are parallel, then I'm also going to have a right angle here, and like we talked about in the one above, this is going to be a right angle, this is going to be a right angle, and this is going to be. So I have right angles everywhere. And again, this is very similar, but like kind of the reverse aspect is, hey, if I do end up with two parallel lines, or if I do end up with two right angles, then I can say that angle or line M and line N are parallel. Because I have those two right angles, I can say with certainty that line M and line N are parallel. So if I look at my first example here, are these lines parallel? I don't know. I have no idea. Well, let me think. This is angle Y. This is also angle Y. These two angles are next to each other and create a line. That's the definition of a linear pair. So again, linear pairs are adjacent and add up to 180 degrees. Okay? So if they're adjacent and add up to 180 degrees, they have to be the same, which means this 90 degrees has to be this 90 degrees. And if this is 90, this is 90, and I see that I have a right angle right here and right here. So again, that looks to me like the lines perpendicular to a transversal theorem. So I would say we used theorem 3.b, because again, I had two congruent angles that were linear pairs. So because of theorem 3.b and the lines perpendicular to a transversal theorem. So, let's say yes. You can say the definition of a linear pair, or you can say yes, let's say theorem 3.b So again, I'm just saying the definition of a linear pair means they add up to 180. They're next to each other, so I have 90 and 90. And then theorem 3.12, which is this guy right here. Okay, find the value of x. Well, again, Mr. Larson's favorite thing to say, little angle plus little angle equals big angle. So I see that I've got a little angle of x plus 20, a little angle of x, and a big angle of 90 degrees. So I'm going to say x plus 20 equals 90. Combine your like terms. 2x plus 20 equals 90. Subtract 20. 2x equals 70. Divide by 2. X equals 35. Again, I could, if the question asked me to find the specific numbers, I could plug this in. 35 plus 20 is 55. That's 505. And then x is just 35. 35 plus 55 equals 90. So we know we did it correctly. All right, so again, using this idea where, hey, if I've got a right angle in one quadrant of my line, I'm going to have right angles all the way around it. Because otherwise, if I didn't have a right angle, it wouldn't be perpendicular. So that means that this right here is a right angle as well. So again, little plus little equals big. I'm going to take 3x plus 2x minus 5 equals 90 degrees. 5x minus 5 equals 90. Separate my left and my right. 5x equals 95. Divide by 5. And you get x equals, what would that be, 19? Yes. So we can apply these theorems, we can apply these rules to, again, prove that lines are parallel or find specific values of x.